Bismillahirrahmanirrahim. Assalamualaikum and greeting. Continue chapter 2, energy. Chapter 2.12, wind energy. So wind power is the conversion of wind energy into a useful form of energy, such as using wind turbine to make electrical power, windmills for mechanical power, wind power pumps for water pumping or drainage, or sails to propel ships. The term wind energy or wind power describes the process by which the wind is used to generate mechanical power or electricity. Wind turbines convert the kinetic energy in the winds into mechanical power. This mechanical power can be used for specific tasks such as grinding grain or pumping water, or a generator can convert this mechanical power into electricity to power homes, businesses, schools, and the like. This is an example of how loud is a wind turbine. Wind turbine. Wind turbine, like aircraft propeller blade, turn in the moving air and power an electric generator that supply an electric current. Simply stated, a wind turbine is the opposite of a fan. Instead of using electricity to make winds like a fan, wind turbines use wind to make electricity. The wind turns the blade, which spins a shaft which connected to a generator and make or produce electricity. Type of wind turbine. Modern wind turbines fall into two basic groups: horizontal axis and the second vertical axis. The horizontal axis variety, like the traditional farm windmill used for pumping water. Vertical axis design, like the egg-beaten style Darius model, named after its French inventor. Most large modern wind turbines are horizontal axis turbines. This is an example of the horizontal axis wind turbine. The axis of rotation is parallel to the ground. The blades are faced in the direction of wind and spin around a horizontal axis when pushed by the wind. Thus, the turbine can convert the wind's kinetic energy into electrical energy. Vertical axis wind turbine. The blades spin parallel to the ground so that they can operate anywhere regardless the wind direction. Is a figure of the horizontal axis wind turbine, which is the rotor blade is facing the direction of air flow, and they have a gear and generator. Uh, okay, and vertical axis wind turbine, which is the shape just like egg, and gearbox and generator is underground. Hydropower. Hydro has been one of the main sources of power for 500 years and more, and blossomed with the invention of the overshot wheel, which efficiently converts the power of falling water to useful mechanical energy. Hydropower converts the natural flow of water into electricity to light our home and power our industries. The energy is produced by the fall of water turning the blade of a turbine. The turbine is connected to a generator that converts the energy into electricity. How is it generated? Electricity. Hydropower is actually generated quite simply as long as there's movement of water. It is possible to generate power because water is 500 times as dense as air. Even a slow stream will generate power as a result. When the water moves through them or a confined space, it begins to rush faster as a result of more water going through a smaller space. When it does this, it turns turbine that then have to power a generator. The generator then sends power into batteries and converts in order to send power out or store it. Advantage and disadvantage of hydro turbine. The main advantage of hydropower: power is usually continuously available on demand. This is advantage. Second, given a reasonable heat, it is a concentrated energy source. The energy available is predictable, no fuel and limited maintenance are required. So running costs are low compared with diesel power. And in many cases, imports are displaced to the benefit of the local economy. It is a long-lasting and robust technology. System can last for 50 years or more without major new investment. The main disadvantage of hydropower are: it is a site-specific technology and sites that are well suited to the harnessing of water power, and are also close to a location where the power can be economically exploited are not very common. There is always a maximum useful power output available from a given hydropower site, which limit the level of expansion of activities which make use of the power. River flows often vary considerably with the season, okay, especially when there are monsoon type climates, and this can limit the firm power output to quite a small fraction of the possible peak output. Lack of familiarity with the technology and how to apply it inhibits the exploitation of hydro resource in some area. From water to power. To know the power potential of water in a river, it is necessary to know the flow in the river and the available head. The flow of the river is the amount of water in meter cube or liters, which pass in a certain amount of time across section of the river. Flows are normally given in cubic meter per second or in liter per second. Head is the vertical difference in level the water fall down. Okay, this is a theoretical power available from a given head of water is in exact proportion to the head h and the flow q. Okay, this available power will be converted by the hydro turbine in mechanical power, as a turbine has an efficiency lower than 1, which is not 100% convert to the power. The generated power will be a fraction of the available gross power. Type of water turbine. So they have two types: reaction turbine and impulse turbine. Okay, this is a reaction turbine. Francis and Kaplan turbine. This is impulse turbine. Water wheel and Pelton. Okay, that's all.